Welcome to this explainer. Today, we are going to take a seriously cinematic journey through our completely dynamic planet. We're looking at the Earth not as some static rock just floating out there in space, but as a living, breathing system of interconnected forces. From the very depths of the ocean to the fiery vents shaping our crust and the swirling atmospheric currents way up above, we're going to explore the science, the systems, and ultimately our survival on this ever-changing world.
Which brings up a huge question, right? A question that gets right to the very heart of humanity's fragile existence here. Are we just totally at the mercy of a restless planet? Or can science actually predict its next move? I mean, every time we see a natural hazard on the news, it just feels like chaos. But, as you'll see today, through the lens of verified science and observation, there are some really profound patterns at play. So, let's just dive right into this.
Okay, jumping straight into part 1, the restless Earth. And moving right along to part 2, El Niño and extreme weather. So to really wrap our heads around these global patterns, we first have to look up at the sky and out at the oceans. It's wild because a single phenomenon out there can have a massive ripple effect worldwide. Take El Niño, for example. Put simply, it's kind of like the ocean's heat engine just shifting into overdrive. When the surface waters in the eastern tropical Pacific get unusually warm, it disrupts atmospheric circulation on a truly massive scale. And according to the World Meteorological Organization, a strong El Niño intensifies major changes in rainfall and temperature across the entire globe.
And look, these invisible ocean currents and atmospheric shifts, they have incredibly real, devastating impacts right down here on the surface. Just look at the data from recent observations. The WMO noted that Western Europe literally experienced its hottest June on record. NASA's Earth Observatory reported raging, destructive wildfires in Spain and France, all fueled by these sweltering heat waves and prolonged droughts. Meanwhile, down in the Caribbean, we saw the Great Atlantic Sargassum seaweed belt hit near record levels. And over in the U.S. Midwest, severe thunderstorms and flash floods just swept right through communities. These absolutely aren't isolated incidents, you guys. They are symptoms of a shifting global system.
So you might be wondering, what exactly is fueling some of these shifting climate patterns? Well, data from Our World in Data shows that global CO2 emissions have pretty much remained at just below 5 tons per person for over a decade now. And while this baseline fuel obviously varies wildly from country to country, the burning of fossil fuels is essentially adding more energy into our atmosphere. And that extra energy, it amplifies the effects of natural climate patterns like El Niño.
Which brings us down to part 3, the shifting ground.
If we literally dive deep underground, we find these immense tectonic forces actively shaping the Earth's crust. The plates that make up our planet's surface are just constantly in motion. And sometimes, well, that motion gets pretty violent. Just check out this hard data recorded recently by the USGS and the European Mediterranean Seismological Center, or EMSC. Within just a few weeks in the summer of 2026, we saw some massive seismic events. We're talking twin magnitudes of 7.5 and 7.2 in Venezuela, a powerful 7.3 earthquake striking right near Puerto Madero, Mexico, and a violent 6.8 magnitude quake in Uto, Japan. The ground is literally shifting beneath us.
And here is why this matters so much. What you really need to take away from all this. It's not just rocks bumping into each other. It's the immense human stakes involved. According to the Smithsonian's Global Volcanism Program, there are 10 different volcanoes worldwide that have over 1 million people living within just 5 kilometers of them. That is a staggeringly massive population living right next door to our planet's fiery vents.
Let's heat things up a bit with part 4, Earth's fiery vents. You've probably seen the recent USGS alerts at volcanoes like Great Sitkin up in Alaska or Kilauea over in Hawaii. These geological features are just a constant reminder of the molten engine churning inside our planet. And honestly, when you see non-stop news alerts about natural disasters, it's super easy to ask this question. Is volcanic activity actually increasing globally? I mean, it certainly feels like it when every single eruption is being broadcast live straight to our smartphones, right? Are we entering some kind of new era of catastrophic volcanism?
Well, let's separate the verified science from the misconception here. The myth out there is that global volcanic activity is rapidly increasing, but the reality, which is completely backed up by the Smithsonian Global Volcanism Program, is a resounding no. Having 40 to 50 ongoing eruptions at any given time, that's completely normal. Actually, since the year 2000, there's been an average of 78 total eruptions each year. So it's not that there are more eruptions happening, it's just that our technology and our monitoring systems have gotten incredibly good at detecting and reporting them.
To really put this whole thing into perspective, just think about this number, 1,215.
That is the total number of Holocene volcanoes that have been active over the last 12,000 years. Out of all those, only a tiny fraction are actually erupting right now. Our planet has been venting its heat exactly like this for billions of years.
All right, let's zoom way back out for part 5, watching from above.
The really cool thing is, we know more about these systems right now than ever before. Humanity isn't just passively sitting around enduring these forces, we are actively fighting back with data and this incredibly impressive global monitoring network. For example, NASA's SWAT mission is continuously measuring rivers all across the globe, while their PACE mission is keeping an eye on ocean health and plant life. Over in Europe, the Copernicus Sentinel-2 satellite provides data that helps scientists assess weird environmental anomalies, like this recent mass stranding of dead shrimp on the beaches of Oman, which is likely linked to changing ocean temperatures. And we absolutely can't forget the astronauts up on the International Space Station capturing these real-time orbital views of monstrous storms like Hurricane Milton. We are literally watching the Earth breathe from orbit.
But hey, observation isn't just happening from space. Actually, it's happening right in your pocket through this totally fascinating pipeline of citizen science. Think about it. When an earthquake happens, eyewitnesses can instantly submit crowdsourced data using tools like the EMSC's LastQuake app. Within moments, seismological institutes combine that on-the-ground reporting with hard data from scientific sensors to verify the event. And this is what allows rapid public safety alerts to be distributed out to millions of people, actively saving lives. It's just a beautiful synergy of human observation and strict scientific rigor.
And all of this monitoring, from the high-tech satellites in orbit to the simple apps on our phones, it brings us back to why this matters so much. As Celeste Salo, the Secretary General of the World Meteorology Organization, so eloquently put it, let us ensure that Earth information is not only collected, but also understood, accessible, and actionable for all. Because at the end of the day, data is really just numbers until we actually understand it and use it to protect ourselves and our communities. We've seen how our restless Earth functions as this giant interconnected puzzle of shifting plates, fiery vents, and swirling oceans. We've seen exactly how science and data are helping us predict and survive its next moves. But look, the planet is vast, and our understanding of it is always evolving. So I'll leave you with this to think about. With satellites constantly watching from the sky and sensors listening deep down in the rock, what undiscovered forces are brewing just beneath our feet or right above our heads, just waiting to shape the next chapter of Earth's history? Thanks so much for watching, and keep exploring.